involved with biochemistry research at Samford University. And this summer I was working with an enzyme called CSE.
And I was in the same lab as Mallory this summer, and we both worked with Dr. Corey Johnson. And my research was done through a research experience for undergrads funded by the NSF, and I worked on a different enzyme called lacase.
Okay, so let's talk about, I'm not a scientist, so can you both of you, can you explain to me, without too much science, what you guys did?
Yeah, we like this question. This is a great
Absolutely.
question.
Yeah. So basically, I was trying to purify a protein. So CSE is a protein in the human body. However, we can't grow human proteins in the lab as easily as we can grow bacterial proteins. So basically, we had to clone the gene that codes for the human protein into a bacterial host. And so I was able to grow that. The host we used was E. coli, and we grew that this summer and worked on optimizing ways that we could purify the protein so that we could do further testing on it.
And the enzyme I worked from it's secreted. It comes out of a fungus that you can find pretty much anywhere. The nickname for the fungus is turkey tail, and it's just a white rot fungus that looks like a turkey tail. And so it's one of 3 enzymes that's secreted from that. And basically, I was studying the enzyme kinetics and the rates of oxidation and how the enzyme works to speed up reactions, so that we can apply it to a bioremediation system, which is basically just using environmental science, using this enzyme for better remediation systems of cleaning our wastewater. So right now there's a lot of estrogens that come from like birth control pills and stuff like that still have estrogenicity, and it's causing really detrimental effects in the environment. It's feminizing male fish and doing lots of other things. So basically, we wanted to figure out how to best apply lacase to a system that can remove the estrogenicity from our wastewater treatment facilities.
So, Hannah, right?
Yes.
You are working on a way to clean up our water so there's fewer estrogens.
Exactly.
Mm-hmm.
Yeah.
That's
it.
That's it.
Yes.
Why should I care about what you're doing?
Because it's involved in Huntington's disease.
Okay.
Yes.
Okay. All right. So you're working on a potential treatment.
Like a regulator for an enzyme that plays a role in Huntington's disease.
Okay. So you're working on a way to prevent the onset of a very rare but really detrimental.
Severe. Yeah.
Boom. That's it.
Okay. It's not the onset though. It's technically like there's been a recent study that shows increase in my enzyme shows less severity in Huntington's disease. So we're working on making it a less
decrease
severe.
the effects.
Yeah. Decreasing the
with
effects
people
of
that already
Huntington's
have
disease.
Huntington's.
Okay, but I'm just trying to
You got
go
it.
to the point
Yeah.
where you can talk about it. And
Yeah.
You can always say, it's really a lot more complicated than this. But basically what I'm doing is I'm working on a way to keep estrogens out of the water.
Mm-hmm.
And I'm working on a way to lessen
The effects of Huntington's.
The effects of Huntington's disease.
Okay.
Yep.
Yeah.
There you go. So terrific. So tell me your backstories. How did you guys, 11, 12-year-old girls really love science. By the time they're 16 or 17, not so much. How did you guys come through?
You want to go first?
Yeah, I had an awesome chemistry teacher in high school. She just taught me everything about chemistry and did it in a way that it was fun and easy to understand. And she was really good at explaining how important it was to understand the chemistry behind things that we were learning and how it impacted our day-to-day lives. So that was
Hannah,
amazing.
could you take just a little step
Oh,
here?
sorry.
Because you're drifting off.
Sorry. I like listening and backing up to people. Yeah, sorry about that.
Your story?
Yeah, so I think I was really lucky to just have this passion from a really young age that not a lot of people have. Some people don't really know what they want to do as they're growing up, and they might figure that out in college. But I remember as a 7-year-old saying, if somebody asked me what I wanted to do, I'd say find the cure for cancer, and I was very sure about that. I don't know where that came from, but I've always loved science, and so I just kind of had that passion in me that kept me going all the way through junior high and high school, and really led me to the college where I am now with their strong science program. And I've had wonderful faculty who really push me and believe in me at my college, which has been so much more motivating than my passion alone. So that's really helped drive me and my research and having the opportunities that I've had in science. So,
What are your hopes and dreams and aspirations?
good question.
I want to be a doctor. That's what I hope to one day.
Oh, your sash fell.
My sash.
This is so important.
There we go. Okay, so yeah, I hope one day to like go overseas and to be able to take the knowledge that I have in healthcare as a physician to people who don't have easy access to good medical care, and so that's what I hope to do one day.
I think that I realized around junior high and high school that saying that I wanted to find the cure for cancer was probably a little lofty, and I learned kind of what that meant. But I've always been intrigued in research, and this past summer was my first experience with research, and I really loved it and enjoyed it. I also am hoping to pursue a medical degree, but I really like the research world, so I hope to stay in the academia side of medicine. So,
Anybody you want to say hi to from Memphis?
Doesn't everybody say hi, Mom? Is that like
Yeah.
a thing? Well,
Yeah.
hey, Mom.
hey,
Hey,
Mom.
Dad.
Hey, Dad. Hey,
Oh,
sis.
hey, Dr. Johnson. That's
Our
our
research
research
mentor.
Yes.
Say what you're
Shout
gonna
out,
do.
shout
Hey,
out.
Dr. Johnson. Check us out with our sash.
We earned it.
Thank you, ladies.
Thanks.
Yep.